Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have understand different types of the degradation, in which we have seen the mechanical degradation. And later we have understand what do we mean oxidative degradation of the polymers. If you have missed that video, you can find it in the I button on the top of the screen. Now, having said that, let's just move to the today's topic. In today's topic, we are going to discuss new type of the degradation, and that is the photo degradation. As you can see here on the screen that the photo degradation is mainly responsible due to ultraviolet rays coming out of the sun. You may have noticed that your white cloth, such as like this white t-shirt, after long uses or after certain time of the washing, it turns to the yellows. As you can see here in the screen that this is the white t-shirt that is the freshly borrowed. But after some time or after some use of the or after some washing, it becomes yellowish like this. So this is the main reason behind the photo degradation of the polymers. Here this t-shirt or shirt is being manufactured with the help of fibers, and these fibers are nothing but your natural polymers. So the ultraviolet rays coming out of the sun directly affect this polymer and turns its color, right, and it degrades the polymer, and we can actually physically see the degradation of such polymers. This is the example of only clothes, but this phenomena is also being observed in a different type of the plastic polymers or even the transparent materials, such your silicone case, that is that you are using for the mobile protection, that is also being material of the polymer, and it is transparent in nature. But after some long amount of usage, this transparent material or the transparent case of mobile phone becomes yellowish. So that is nothing but the effect of UV rays on the polymer, and this termed as the photo degradation of the polymer. And this photo degradation we are going to see here in much details. So as you can see here on the screen that this type of the degradation is brought about by UV radiation, as I have already discussed. Yellowing of white cloth and some transparent plastic such as your mobile case is due to this interaction of the ultraviolet light with the polymer. The degradation of the polymethyl methacrylate is in a molten state gives on a radiation 100% of the yield. That means this PMAA material will directly degrade and it will form 100% of the monomers. But if this material is in a molten state, if this material or this specific polymer is in a solid state, then it will not give 100% monomer. So as we have already seen in the previous lectures, when polymer degrade, it forms different monomers, right? It decomposes into the monomers. So this polymer, when undergo the photo degradation process, it also decomposes into the monomers. But if the polymer is in a molten state, then it will give 100% yield of the monomers. But with the case of solid state, 100% of the yield cannot be achieved. So similar to the previous degradation processes, in a photo degradation also free radical is being generated. So this is the main reason behind the photo degradation process. This ultraviolet rays produces a free radical out of the polymer. As you can see here, during photo degradation, free radical is being generated, and further reaction of the free radical is dependent on the physical state of the material. So the further degradation after your free radical is being formed is purely dependent on the physical state of the polymer. As we have already discussed, if the polymer is in a molten form, then it will follow different type of the degradation. If the polymer is in a solid state, then it will also follow one more type of the degradation process. So based on the state or physical state of the polymer, this degradation can be defined, right? Can be of a different types. So now having said that, let's just understand this photo degradation process with one example. As you can see here on the screen that I have taken the example of the PMAA. PMMA that we have understand in the previous slide. So as you can see here on the screen that this is the structure of the polymethyl methacrylate. So you can see here it has CH2, CCH2. On the above side we have CH3 and at the below we have C double bond O and OCH3 attached to it. So this is the monomer and this monomer are combined together and number of monomer are being combined together to form long chain of the polymer. So when this polymer of PMMA is being affected with the ultraviolet rays, it decomposes. As you can see here, two different structure is being produced. As you can see here, this particular bond, right? Let me just take a pen here. This particular bond will break up because of the ultraviolet rays, and this bond will be equally shared by both the carbon, as this carbon will have one pair of electron and this carbon here will also have one pair of the electron. So we can say that on the application of the ultraviolet rays, there are free radicals which have been generated. As you can see here, this is the same carbon that I am representing, right? This carbon has now one free radical. Since you can see here, this is the free radical is being generated. Since this bond here, this bond is now broken up, right? Because of the ultraviolet rays. So you can see here one free radical is being generated and this is the same structure, right? But now this particular chain of the polymer is now separated, as this chain C double bond O, OCH3 is now separated. As you can see here, we have O double bond C, OCH3. And this particular carbon also have one free radical because that bond has been shared by both the carbon in an equal amount. So at the end of the degradation, we are left with the two products. One is this one and another one is like this, right? Linear product. Both the production will undergo the different type of the reaction and they will differently degrade. So let's first understand this chain polymer or the chain product coming out of this particular chain product first. As you can see here, this is the same compound that have been generated in a previous reaction. That is O double bond C dot OCH3, right? This is the compound that I am discussing here. This compound is now reacted with one monomer of the PMMA. Right, as you can see here, it is being reacted with this. So now what will happen is, this free radical will abstract hydrogen from this particular CH2 group, right? So, and it will form one more product. As you can see here, this free radical here, I am discussing about this free radical will now abstract hydrogen from this CH2. So what will happen, as you can see here, this product is being generated. We have O double bond C and it has connected with one more hydrogen that is being abstracted from this CH2, and we have OCH3 as it is. And here you can see that here we have one deficiency of the hydrogen. Here we were having CH2, but now as a product we are only left with one hydrogen, and the free radical is now moved to this particular carbon like this. Okay, so this is what happened when your one of the product from the photo degradation goes in a degradation process with the one more molecule of the PMMA. Now if you carefully look at this particular product, you will observe that this is the methyl format. So as you can see here, on the decomposition or you can say photo degradation of the one polymer, it produces another useful product, right? So this methyl format is again very much useful in a different industries. Now after understanding this, let's just focus on the second product that we have obtained from the first reaction, and that is this one, right? So let's see how this particular product will undergo the photo degradation process and what are the different products that will be generated. As you can see here, I am discussing about this particular product, right? As we have already discussed in a previous slide, this product turns out into the methyl format. Now let's understand what the product we will get when this particular component or molecule decompose, or we can say degrade in the ultraviolet rays. So I am represented this same molecule here. This is the same molecule, and on the application of the ultraviolet ray, as you can see here, this particular bond between carbon and CH2 will break up. Right, on the application of ultraviolet waves, this particular bond will break up and it will share by both the carbon atom, this and this, right, in an equal amount. As you can see here, I have already represented with the arrows that this bond will break up and it will be shared in an equal amount with the both of the carbons, right? So now as a result, you can see here, this carbon has one free electron range. As you can see here, this carbon has one free electron and this carbon is also having one free electron, right? So we can see here two radicals have been generated. Since this is the CH2 is now linked with this carbon in a double bond, because it was having one free radical, so better it will make the double bond. So on the application of the ultraviolet waves, we are getting different product. As you can see here, we are getting this product and we are also getting this product, as both the things are now separated because of the breakup of the bond, right? And this breakup of the bond is being only possible with the energy of the ultraviolet rays. So this is how photodegradation process works, and we have already seen two examples of it, right? In a previous example here, we have understand how this photodegradation of PMMA product will take place, this one, right? And it will produce two different products. One is this, here you can see that one is this, and another one is this, the straight compound, right? And both the compound will undergo the different types of the reactions. And we have seen what are the different products that we are getting from the, and we have seen what are the different products we will get from this from this photodegradation process. We will get this methyl format, and with the help of secondary reaction, we will have two different products like this one and this one, right? A similar kind of the photodegradation is being also observed in different compounds. As you can see here, I am representing one more example of largely known polymer of the polyethylene, right? We have already understand what do we mean by the polyethylene. It is the polymer made up of the ethylene monomers, right? So as you can see here, similar photodegradation is being observed in the case of the polyethylene molecule. So how this linear chain polymer will undergo the effect of the ultraviolet rays, and how it will be decomposed into the and how it will undergo the photodegradation process. Well, answer is very much simple, that this polyethylene is not in its pure state. Some amount of impurities are being always present in the polyethylene, and these impurities is being responsible for the extra linkage of the C double bond O or C double bond C. As you can see here, the impurities present in the polyethylene will now responsible for the makeup of such bonds, that is C double bond C and C double bond O. So we are very well know that polyethylene is a linear polymer like this, in which CH2 are being connected with each other. But you can see here we have one C double bond O, and this C double bond O is only responsible because of the impurities that are present in the polyethylene. So these impurities can be by the production method, or it can also represent defected polyethylene molecule. So because of these impurities, we will now have photodegradation of the polyethylene. As you can see here, on the application of the ultraviolet wave, the delta carbon, you can see here, if this is your alpha carbon, then this is the beta carbon, then gamma carbon, and the delta carbon. So this delta carbon will break up and it will generate free radicals. As you can see here, now on the application of the ultraviolet waves, this delta carbon bond is now broken up and it will share with the both of the carbon. And because of that, we will now have bond between carbon and hydrogen here on the delta carbon will break up, and this bond will be shared by the both of the carbon in an equal amount, right? So as a result, you can see here, this carbon has made one more pair, or we can say one more bond with the gamma carbon. As you can see here, this gamma carbon and delta carbon are being connected with each other with the double bond, and they have lost one hydrogen. So because of this ultraviolet radiation coming out of the sun degrade our polymer, and it is responsible for the physical change of the polymer. This is the example of ethylene molecule. In a general, ethylene molecule do not undergo the photo degradation process. But because of the impurities present in the polyethylene molecule generate carbon double bond, such as C double bond C or C double bond oxygen. And this C double bond oxygen or C double bond C is the main reason behind the photo degradation of the polyethylene. And it will directly attack on the delta carbon of the polyethylene chain, and it will abstract one hydrogen like this. Here you can see that we have CH2, and here we have only carbon, one single hydrogen, right? And this carbon will make double bond with its gamma carbon. So you have to remember that this alpha carbon is your carbon which has been connected with one functional group. So here the functional group is oxygen. So this is the alpha, this carbon is the beta, gamma, and we have delta carbon. So ultraviolet rays directly attack on the delta carbon. So this was all about the photo degradation. In upcoming videos, we will understand how we can restrict this photo degradation process by using stabilizers. Till then, keep watching, keep learning. Thank you.